Today, he will give us a very special talk under the title of Linking Macroscopic, Sub-microscopic, and Symbolic Representations in Chemistry Teaching and Learning. So, ladies and gentlemen, please join me to welcome Dr. Daniel.
If I am speaking too fast and you cannot understand what I'm saying, please stop me and tell me. If you need to ask any questions in Thai, no problem, you can ask. I don't understand, but there will be people who translate your questions into English. Okay, then I'll answer. If you don't understand my answer, then my colleagues in the KKU will translate again back to Thai. So I hope that this will be an interactive session because you are with me for 6 hours. So if it is boring, all of you are going to fall asleep for 6 hours. So I hope that doesn't happen. All right, so let me get started. Dr. Newan contacted me a few months ago to ask if I could present a talk on linking the macroscopic, sub-microscopic, and symbolic representations in chemistry teaching and learning. All right, so I'm grateful for the invitation of the Khon University that invited me here to give you this talk. However, a few weeks before I came, he told me that the audience are not only chemistry teachers, they are also physics and biology teachers. So I had a little bit of a problem because I'm not a biology or physics teacher. But I will try to put in something. So that's why I put and others. Alright, so at the end, I will try to put in something about physics and biology representations. I hope it will be useful. But most of my talk today will be on chemistry. But I hope that you can translate what I'm saying into examples that you can use in physics or biology education. Okay, the introduction. When I met some of the students from Khon University, they mentioned that philosophy is very difficult. Philosophy of science, nature of science is very difficult for a science student. Right, BP, where are you? Where is BP? Still not here yet. Okay, so, alright, but philosophy is very important because it sort of guides the way that we think about science and how we teach science. So, I'm going to start with this first. Can you see this diagram of mine? Okay, for about 30 seconds, I want you to look at the picture. And I want you to quickly write down all the names of the animals that you can see. Okay? It can be in English. Okay. Since I'm here, it's a good time to practice your English. So write down the names in English. Okay? Now, number 1. Can you see the dog? Number 2. Can you see the cow? Number 3. Can you see the cat? Okay, not the lion. Not the lion. The cat. I give you another 30 seconds to try and find them. Okay. How many of you can see the cat? There's that one. Cat. Okay, good. Okay. The dog is somewhere on the tree. Bigger. Correct. This is the answer on top of that. Right. Thank you. So how? Can you see it? It's a tree And you have to look at it this way. The legs, the tail, the body. Okay, last one. The cow. Where is the cow? You got to look upside down. The cow is upside down. The cow is near the water. Near the water, near the tree, or framed by the water and the tree. Can you see that? When look at the patch there. Thank you. Thank you. This is the head, the legs, the body, and the tail. Can you see? So, I have the prior knowledge, which you don't. So, you cannot see. But now, I have already taught you how to see. Okay? So, it's just like science. Because science is a different way of seeing things. Right? We teach our students to see things in a very different way. Right? It's not only facts, the science concept, theory, but also how we see things. So, a bit complicated, but when we teach students science, we are actually giving them new eyes to see the world. Alright? So we have new eyes to see the world with the eyes of another, the eyes of a scientist. Okay? So science, it will not be useful for students if they cannot see the world in the eyes of the scientist after we teach them or we have taught them. Okay, I think for biology, physics teachers, this is quite familiar to you. The formation of image on the retina. Okay. Can you describe to your friends, to you, how the eye sees this capital letter A? Okay. How we see the image of A. So, to see A, either A is a light source, so that light will be emitted of A, or light is reflected from A to the eye. Correct, Nana? Physics teachers, am I correct? Okay, so now we come to the biology part. Okay, I'm not sure. Okay, so this one, the terms, okay, this one I have to state clearly. Because when I teach science in English, there are some problems with the meaning of the word in English. But if you teach science in Thai, there may or may not be the problem. Okay, because the Thai word may not cause problem, or sometimes the English word cause problem. And I'll discuss this. Alright, so the light will hit cornea, right? Okay. So you will pass through the aqueous humor. Okay, go through the pupil. Alright, hit the lens. Okay, here it's a different medium. So physics will know that there will be refraction inside also. Right? And the light will also be refracted here and then go through the vitreous humor. Hit the retina, then you will activate. So this is black and white, so I think it's a code. Rods or codes. Rods or codes. Because color is something else, right? Okay. Now I have to ask the physics teachers again. Property of the image. What will be the property of the image found on the retina? Yeah. Right. Diminish, smaller, right? image is formed upside down. Is the world that we see upside down? I repeat, if the image that is formed is upside down, are all of you upside down? Actually, I don't know whether you're upside down. But the interesting thing is that after the image is formed here, there will be signals, right? Some nerve impulses that goes to the optic nerve and goes up to the brain. I don't know which part of the brain, I can't remember. Alright? But the interesting thing is that, do we see the A, or do we see what our brain wants us to see? We don't see this, right? But we see the signal, everything go to our brain, and then we see what our brain wants us to see. Okay, we don't see the thing. Right? Because it just formed the retina, and everything else is made by the brain. Okay, this one is very important in science. It has a lot of consequences. Okay, there are some words. Let me have a look. Johnson, what he says is that there is something outside. But what we see is not what is outside, but what our brain wants us to see. Right? Do you follow English Premier League football? Do you follow? Okay, just show of hands. How many of you are supporters of Manchester United? How many? Only one. How many of you don't like Manchester United? Two. At least there are two, there are three. Right? You see, Manchester United is just a football team. But why does some people like it, some people don't? It is the same thing. But how we feel about it is different. Because we will have to perceive it differently. We are different people, we see things differently. Okay, just like this. Look at science. What Einstein says about science. Now, if we compare it, Einstein says that science is a creation of the human mind. All the ideas are invented. So, in colloquial English, it means we cook up the theory. Okay. Theory comes from man. It doesn't come from the phenomena. Man will have to understand the phenomena. Right? It is so. All our theories are our invention. Just like here, okay, we are because we cannot see what is outside. We see only what we want to see. Okay? So this is very important in science because if science is the truth, then no need pedagogy. Memorize. You memorize, your students just memorize everything because they cannot go wrong. It is the truth. That's the best way to learn truth. You memorize. Because you cannot go wrong. But if science is not the truth, and you memorize it, what happens if it is wrong? When you memorize something, you do not know whether it's right or wrong. Or when you teach students to memorize, they have to understand so that they can decide in the future what is right or what is wrong. Everyday life. How many of you like to drink coffee? Okay, question. Is coffee good or bad for you? Do you see newspaper reports? Sometimes say coffee is good. Then after that, coffee, no, coffee is no good. Then again, coffee is good. No, coffee is no good. Especially if the research is supported by Nescafe, it will be good. Alright? So we can see. Then the students will say, science, if we teach students just that science is true and memorized, and we memorize it, then why do scientists cannot agree whether coffee is good or bad for you? Next thing, your handphone. Okay. Is the radiation harmful or not? Okay. Does the radiation fry your brains? We don't know. Right? Or maybe we don't want to know. So imagine if the telecoms company built a base station on top of the building where you live. Will it be good for your health or not? But sometimes we have to make a decision. Let's say you live in a building. Will you allow the telecom company to build a base station on the building? Apparently in India, there are reports that the rate of cancer is very high when people live in those buildings when the base station are built. Okay? So we don't know. But many scientific reports say it's harmless. Especially, of course, it is sponsored by the telecoms company. So sometimes your students must make decisions in life using science. Okay, make decisions in life. Can you hear me, guys? Can you hear? Okay, make decisions in life using science. But if we teach them to memorize only, it's very difficult for them to do so. They have to understand, they have to argue about science. Understanding is more important than knowing. Let me give you a few more examples. When we teach science, we are teaching students to see how a scientist sees things. Right? We are teaching students how to think, how to talk like a scientist. So how to see the world differently. Now, kinetic particle theory says that all substances are made of particles. Alright? And there is vacuum between particles. Your students will tell you, hello, where are the vacuum? Where is the particle? I cannot see. You tell me that, but I cannot see. So, to learn science, your students must believe that you're telling them correct things. If they don't believe you, you cannot believe them. Because, especially on chemistry, you're teaching them things which they cannot see. Chemistry is very difficult. You cannot see. And sometimes it is against what they experience in daily life. Now this one is pure. In daily life, this is orange juice. 100% pure orange juice. Have you all seen this before? Not a brand, just 100% pure orange. 100% pure orange juice. Chemistry teachers, is there such thing as pure orange juice? What do we teach students? What is pure? Pure means make up of only one thing, right? Orange juice, make up one thing only? No. You have water, you have sugar, you have orange, sometimes you have the insects also inside. It is not pure. When we use the word pure in chemistry, it means something different. But in the world, pure orange juice means what? What does it mean? Just orange only, right? And something we add water also. It's just for orange. By chemistry, no such thing as pure orange
is a mixture. So the words that we use in science, the words that we use in real life, may not be the same. In Thai, we have this problem. Same thing, pure in chemistry and pure in my orange juice, you have the same problem. Not really. If you use different terms, then it's different. Like English, it will create some problem. Now, share. Okay, share. The word share in English. Now, I want to share with you. What happens? We will share one, right? But can I say, you want to share with me? I say yes. Okay? Yes. Where is your orange? You don't have, how can you share with me? In everyday life, when we share one, right? Or like I say, I want to share with you. Can you share? You want to share with me? Yeah? They say, okay, she must contribute one also to share. Is it like this in everyday life? But in science, we teach them we share. Okay, each one must take one, must give one. So when we share the form of covalent bond, alright, each one must give one. Very funny. In daily life, we just share one only. By covalent bonding, each one must take up one. So it's so totally different from everyday life. That's why I say chemistry is very different. Okay, perhaps I give you about 1 minute to talk about what I shared with you and to see whether you have any questions to ask. So, maybe you want to discuss with your colleague for 1 minute.